Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X, published on August 8, 2025, which was about 7 days ago. The standout result is that filtering dual-use biology from pre-training data makes open-weight models durably resistant to tampering, staying robust through up to 10,000 fine-tuning steps and about 300 million tokens, without hurting unrelated capabilities. The paper is titled, Deep Ignorance: Filtering Pre-Training Data Builds Tamper-Resistant Safeguards into Open-Weight LLMs. And as we will see later, the implications for model training are quite significant. Beyond robustness, the approach is low overhead and complements post-training defenses, though retrieval still bypasses ignorance. Building on that, the tweets highlight that filtering dual-use biology during pre-training boosts tamper resistance by over 10 times, preserves other skills, and releases code and models, drawing moderate engagement. Alright, zooming into the figure, the left bar chart shows general capability averaged across 4 benchmarks, where baseline, weak filter, and strong filter bars sit nearly identical, so broad skills stay intact. Now look to the right time series. As adversarial fine-tuning tokens climb toward 300 million, the baseline curve rises highest, while weak filter rises less and strong filter stays lowest and flattens, hugging the dashed near random line. Building on that, the legend clarifies color mapping for baseline, weak, and strong filter variants. Next, the diagram walks through the 2-stage filter. First, focus on the whole graphic documents enter at the left, then pass through a block list, and sometimes a classifier on the right. The top row shows a clearly risky sentence that triggers the block list and then the classifier, which removes it when the unsafe probability exceeds the threshold. The middle row also escalates, but the classifier keeps it. The bottom row has no block terms, so it is kept immediately. Now, take in the full figure. 3 panels compare general skills on the left, biothreat proxy accuracy in the middle, and robustness under input space attacks on the right. The left panel shows near equal bars across methods, so broad capabilities remain steady. In the center, the filtered variants drop toward the dashed random line, especially on close prompts. Moving right, the filtered bars, particularly the strong filter, stay lowest under GCG-U, indicating stronger resistance, while few shot favors circuit breaking slightly. Okay, focus on the 3 panels together. They track how different defenses hold up under tampering. The 2 line charts on the left show adversarial fine-tuning steps on the bottom and accuracy on WMDP bio on the side. As steps rise toward 10,000, the strong filter curve stays near the dashed random line, while baseline climbs. Moving right, the bar chart summarizes latent space attacks. Circuit breaking plus LAT wins on multiple choice, but filtering wins on close, keeping bars nearest to chance. Alright, this table catalogs the released models and what each variant changes. Start by scanning the full grid to see artifact names on the left and concise notes on the right. Building on earlier results, the rows distinguish unfiltered, weak, strong, and hybrid filters, plus checkpoints after pre-training and annealing. Next, notice the combinations with circuit breaking and with circuit breaking plus latent adversarial training, which boost tamper resistance. Finally, the bottom rows flag these synthetic corrupted knowledge variants, which the authors note did not reliably help. Building on that, 2 takeaways stand out. Filtering dual-use biology during pre-training hardens models against tampering by over an order of magnitude while preserving general skills. And defense in depth remains essential, because retrieval can still supply missing knowledge. Circuit breaking means rule-based refusal training, and latent adversarial training targets hidden representations. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.